This is video number 3 for sections 1.3 and 1.4, finding the slope from the equation. So far, we have concentrated on finding the slope from 2 points. Well, what if you don't have 2 points, or even a graph? What if you just have the equation? Well, this is really the best part and the nicest part, and I think this will probably be by way of review for you. I've written down here our good old equation, y equals mx plus b. We said last time that any equation that is written in this format is always a line, and in fact we have a name for this particular format. It is called the slope-intercept form of a line. The reason for that is that the slope as well as the y-intercept are right there staring at us when we have an equation in this format. In particular, the m, the number sitting there right in front of the x, that is the slope. And the b, the number sitting out there on the edge, that is the y-intercept. This is really fantastic. I can read those two pieces of information right out of the equation. Well, let's try that in this example. It says find the slope as well as the y-intercept, and we're given a line, we're given its equation. Well, as long as it's in that good format, that y equals mx plus b format, we're all set. This one is. I've got a y, an equals, a number, an x, a plus, or in this case, a takeaway. That's like adding a negative and then a number. It fits the format. So if I want the slope, I don't really have to do any work. I can just write it down. The slope very clearly is 4, the number sitting right in front of the x. By the way, that tells me a few things about this line. Would this line be more on the steep side or more on the flat side? Well, 4 is a lot bigger than 1, which means this line would be kind of steep. How about increasing, decreasing, horizontal, vertical? What type of line are we talking about here? Well, the slope is positive, and we've already learned that if the slope is positive, it means that our line is increasing. It's going upward from left to right. One question you might have is, what about the rise and the run? I thought the slope was supposed to be a fraction, and this is just a whole number. Well, remember, we always simplify our final results. If you have a slope that is a whole number, but you, for some reason, would like to write it temporarily as in a rise over run format, you can always insert a 1 underneath any whole number to turn it into a fraction. 4 divided by 1 is still 4. So we would say the rise is 4 and the run is 1. Well, what about the y-intercept? That was the other thing we were supposed to find. Well, that's the b sitting here at the end. The minus means that this really says plus negative 2. So we would say the b is negative 2. If I want to state it as an ordered pair, we saw in the last lesson that the y-intercept always has an x-coordinate of 0, and the b here tells me the y-coordinate, and so my y-intercept is the point 0, negative 2. Another benefit of knowing this is we now have a faster way to draw a graph of an equation, of the equation of a line, than what we were doing last time. So in this example, we're being given a line. Here's the equation. We're being asked to sketch a graph. Well, if I can just come up with the slope and the y-intercept of this line, I'm going to be able to make this graph very, very quickly. Now, if you're looking at this thing thinking, okay, the slope must be 2 because that's the number in front of the x, well, not quite. Remember that pattern that we saw, it only works if the equation is in the proper format, the y equals mx plus b format. So before I start saying the slope and all of that, I need to do some algebra to put this guy in the right format. In other words, I need to get y by itself. That's a pretty quick process. It looks like I need to subtract 2x from both sides, giving me 3y equals, now let's see, I could write 9 minus 2x, but I'm trying to make it look like that y equals mx plus b, so I think I'd rather have the x part first, negative 2x plus 9. And let's see, the y is almost by itself. If I just divide both sides by 3, I think I'll have it. The left is now just y. On the right, I'll go ahead and I'll distribute this 3 into both parts here. So negative 2 divided by 3, that doesn't go in evenly. That just gives me negative 2/3 with my x. And then, let's see, plus 9 divided by 3 is going to be a positive, and that one does work out nice. 9 divided by 3 is 3. So I've taken the original line, I've put it in the good format. Well, now I know, without doing anything else, I know my slope. It's negative 2/3, right? It's in the good format, so the number in front of the x is the slope. And I know my y-intercept is positive 3. If I want to state it as an ordered pair, that would be 0, 3. That's all the information I need in order to graph this line. Let me show you. What I will do is I will start with the y-intercept because I know that that is a specific spot on this graph. So I'll go to the point 0, 3. And then from there, I just need to mark down some other points that are on this line. Now, maybe you're looking at this thinking, but we don't know any other points. That's true, but I have something even better. I have the slope. Remember, slope is rise over run. So I can start with that point we marked and simply count spaces in terms of rise and run to find other points on this line. Before I do that, let me address the negative. When you have a negative in front of a fraction like this, you can either think of the negative as belonging to the top of the fraction, or you can think of the negative as belonging to the bottom of the fraction. In other words, you can either think of this negative 2/3 as being negative 2 divided by positive 3, or positive 2 divided by negative 3. They're both the same. You cannot have a negative on both, because if you were to have a negative on both, they would cancel out. You would no longer have a negative number. All right, why is this important? Well, remember, slope is rise over run. So when I come up here and I'm looking to find a second point, I can either think about the negative as belonging to the top, or the negative as belonging to the bottom. If I do it the first way, this would mean the rise is negative 2. That would mean go down 2, and then the run is positive 3. Positive is to the right, so positive 1, 2, 3. I just found another dot on my line. For accuracy's sake, let's do it again. Down 2, right 3. When drawing on paper, you need to be as accurate as you can. You say, well, what if we had thought of the slope the other way? What if I had thought of the negative as belonging to the bottom? Well, again, here was my starting point, right? And now my rise is positive 2, so from here I would have gone up 2, and my run is negative 3. That would be to the left 3, so 1, 2, 3. Well, do you see it doesn't matter? I still got another point on that same line, whether I went down to right 3 or up to left 3. Let's get, I think I can fit one more point on there if I go up 2 more and then left 3 once again. And then we just need to connect the dots and we've got ourselves our line. This line is the graph of the original equation. Let's make sure that the slope information makes sense. Let's see, the line is going downward from left to right. Does that make sense? Yes, because the slope is negative. Lines with negative slopes always go downward from left to right. What about the steepness, flatness issue? Well, 2/3 pretty close to 1, a little bit under 1, which means this line should look just a little bit flat. And I think that's pretty accurate. It doesn't really look very flat or steep. It's just slightly flat because the slope is a little bit, at least the value of the slope, I should say, ignoring the negative, is just a little bit less than 1. You can become so fast at this that you can draw lines honestly faster than you can get them to come up on your graphing